Good evening, all. In this session, let us discuss about pointers. So, what are pointers? How pointers are to be declared? Let us see. So, in this, before going to declare pointers and know about pointers, let me declare a simple variable and what it means. If I want to declare a variable of I of data type integer, so I will be declaring like this. The value will be 9. This is a simple variable, right, which is holding a value. So now my pointer is nothing but it holds some address. So for which address it will be holding, let us see. Now let us see just how to declare a pointer. If I want to declare a pointer p, if I will be giving like this, it in the sense it is a normal variable. So how can I declare a pointer variable? If I give asterisk p, it in the sense it indicates that it is a pointer variable. Okay, so what happens if you declare this variable in the memory? If I declare this variable in the memory, it gives some space for that particular value. The value is 9 and the address will be 2000, right? So now here I have declared a pointer variable and I said the pointer is nothing but it holds some address. So now if I give here, going back to the normal variables I, j and some k. Okay, for I will be assigning some 9 and for j I'm assigning 10 and for k I'm just assigning some 7. K equals to 7, right? So now I said these are the three normal variables and this is my pointer variable. I said pointer variable is nothing but it points to it holds the address and points to the value at that particular address, right? So pointer variable has to hold the address. So now the question arises, to which variable it has to hold the address. Now my intention is I have to hold the address of I. So first mentioning this, I'll just give p equals to ampersand I, right? So if I give like this p equals to ampersand I, it the my p variable is going to hold the address of I and it points to that particular value. Okay, now the address of I is nothing but 2000 and what the p is holding, pointer variable always holds the address, so it is holding the address of I. Why I? Why not J and K? Because I have assigned, I told the compiler to hold the address of I itself. So that's why uh, my pointer P is holding the address of I, right? So let us quickly see the definition of the pointer. Pointer in C. Let us see the simple definition. What is a pointer? So here pointers are nothing but which holds the memory. Just see here, every variable is a memory location and memory location has its address defined which can be accessed using ampersand. And when coming to the pointers, a pointer is a variable whose value in the address of another variable. That means it holds the address of another variable. If you see here, it is holding the address of another variable I. Okay, so here I want to mention to which value, to which variable's address it has to hold. So for that I am just giving the ampersand I, so that I am telling the compiler to hold the address of I, right? So now let us see the image so that we will be more clear. Just let us see the image so that you will be, yeah, you can see here. Here, this is VAR is a normal variable and it is having the address of 1000, right? So here PTR is a pointer variable, and pointer variable, it has to hold the address of another variable. So it is holded the address of VAR variable 1001. So again, my pointer is also having another address. For that, I'll just show you here somewhere 5000. Okay, it doesn't store sequentially, randomly it will store. So here I'm just repeating again, point, this is my normal variable, some A, right? So in A, okay, in memory I have given A, and the value will be something, I'm assigning the value here only 100. Okay, the value of A is 100 here, and the address is some 2002, right? So I'm having another variable B, and the value is some 585, and the location, like address is 4000 2006. Okay, so here I'm just declaring B also, B equals to 585. This is clear. Now I have to declare a pointer variable. Okay, so I'm just declaring a pointer variable. If I declare like this means, if I declare the integer p like this means it is a normal variable, right? So for a pointer variable, I will use the asterisk operator p, right? So if I give like this, it indicates that it is a pointer variable. Now my question is whether it has to hold the address of A, B or any other variable. That is my requirement. I will just access the, I will just give the address. You just, if you want to hold the address of A, you just give A. If you want to hold the address of B, you just give B. Okay, so that is me, it is deciding to which variable it has to hold the address. So here I have created a pointer variable P, right? And it is having the value, now it is having the value of address of B. So address of B is, it is 2006. So here 2006. So here the address 2006 it is holding, right? Again, for your pointer variable also, you will be having some address, right? So here, this is how you will declare and initialize the pointers. And there will be different types of pointers. Those are null pointers, right? Wild pointers, and you will be having void pointer, void pointers. Okay, so null pointers means we will be assigning, like I'll just show you, star p equals to null, right? So it is not, basically it is not at all holding any of the address. Previously when we are writing the massive programs, we will be guessing, like we will be using the pointer variable, but we are not sure to which variable we have to assign. So that's why initially we are declaring a pointer of type null. So simply by giving star p equals to null, it will become a null pointer with a value 0. So next, going to the wild pointers, star p. Here I am not assigning any value or address to the particular variable. Those are nothing but the wild pointers. And if we give void pointer means I am not giving any data type. Here you will be giving data type for these things also. Okay, int pointer p, and here I'm giving, I'm not sure about the dot data type and I have to return nothing. So I will be giving void star p, right? So this will be the void pointer. Okay, and let us see the types of pointers again in brief, in detail. Types of pointers in C. Okay, so here as of now, basically we will be having the null pointer, void pointer, and wild pointer. Let us see those pointers here. Types of pointers. We'll just quickly go through these things. Pointer declaration, we have seen initializing a pointer, nothing but assigning the address of a variable, we have seen. And the types of pointers here are null pointers. So we are giving the data type and pointer variable and null, nothing but a null pointer. That means like we in the actual memory was not be assigned. We initialize a pointer variable when the pointer variable is not assigned in any actual address. Okay, so we are not sure as of now, so we will be declaring a null pointer. Okay, so next, void pointers. Here every time you will be giving int x10, here just yeah, void p, void pointer, right? So this is the void pointer. And going to the wild pointers, here I'm not assigning any, initializing any address. These are nothing but the wild pointers. Okay, so here a dangling pointers is a pointer that points to the memory location that has been deleted, is called dangling pointer. That means already when it is pointing to the deleted memory location, you will call as a dangling pointer. Okay, these are the basic types of pointers we will be having. And next, like if you want to know the address of a pointer, so what you will be giving, so you will, by using the percentage u, you can get the address of a particular memory location. Like if you want to get the integer value from the memory in the printf statement, you will be giving percentage d, right? So if you want to get the address from the memory, address of a particular variable from the memory, you will be giving percentile u. Okay, so next, going here, let us see the next topic. Yeah, pointers to arrays. So I'm just deleting these things. Pointers to arrays, right? So if I declare an array like this, int a equals to, I can be assigning 1, 2, 3, 4. Yeah, I have to declare an array, right? Not a normal variable, right? So and f5, right? This is, I have declared an array, right? Now I have to assign the array to a pointer. So I have declared int pointer p here like this. So directly by giving the array name, I can access the elements of the array. Okay, so this is how you will assign the address of an array to a pointer, right? So the next concept is it is a pointers to structures. Okay, so how you will declare a structure? So I just declare a structure with the help of struct keyword. If I declare a book like this, and a character, the structure members are character name and price, those are the structure members, right? So I'm just in my main, I'm just declaring structure variable struct, my structure name is book, and structure variable is nothing but a. Okay, So now structure book. Now I have to declare a pointer variable for this particular structure, right? Book is my structure name and A is my structure variable, right? And these are the structure members, right? So for this structure A, structure variable A, I have to assign a pointer. So what I will do is star, I'll just give star ptr. Okay, so I have declared a pointer. Now I have to declare ptr equals to ampersand a, right? So if I declare another structure struct struct book b, some b of 10, you can give like this as well. So here you will be giving struct same wise struct, I can give book star p is another pointer, and for this pointer I'm just assigning b. Okay, assigning the address of. So here for the structure variable a, I'm assigning the ptr pointer, and for the structure variable b, I'm assigning the p pointer, right? So now the thing is, we have declared a pointer to a structure, right? Now the thing, how you will access the structure pointers, the pointers to the structures. The thing is, you have to access these structure members. So I'm just deleting. Okay, fine. I'll just here we have declared a structure, and now we have to access these structure members, right? Pointer structure we have declared, and right now how to access these members of a structure using pointers. So just I'll just give a example. If you declare a structure struct some my underscore struct is my variable structure variable, and here I'm declaring name of 20, and int I'm declaring number, and I'm declaring a rank. So let us quickly see how to declare a structure, how to access the structure members. In my main program, I'm just declaring the structure variable struct. So my structure name is my underscore struct. Okay, so variable is my structure name. So I will be accessing welcome, and the number is some 53, and rank is some second rank. Fine. So I will be accessing the values like this. Next struct, I'm declaring a my struct, my struct equals to star ptr. I have declared a structure pointer for this my structure, right? Now I have to relate. So ptr equals to ampersand. So what is my structure name? Variable, right? Fine. Now I have to access these members, right? Now it is pointing to this structure. Now I have to access these three variables, three structure members. Okay, so how I will be accessing? I'm just giving these things in a printf statement. So name equals to percentile S. Okay, so PTR is my structure name, and with the help of arrow operator, I will be accessing, right? So next, same thing, so that it is pointing to the name. So likewise, I'll be just accessing. The next one is, it is number, right? So with the help of arrow operator, so how you will find the arrow operator in the keyboard? So by giving a minus and a less greater than symbol, you will be having the arrow operator. So with the help of the arrow operator, you will be accessing the structure members. It is a number, it is percentile D, and it is rank percentile T. I can give comma PTR, it's the rank. Return 0 something. Okay, so you will be accessing the structure members by using the pointers like this. And the next thing here we are going to know is use of pointers in self-referential structures. Self-referential structures are nothing but structure within a that is referring to itself, right? Self-referential structures. Okay. Self-referential self-referential structures are nothing but a structure which is referring to the same structure is nothing but a self-referential structure. Okay, see here, he has declared a structure here. If you see here, he has declared a structure here. The structure name is node, and the structure members are here. Data 1 and data 2 are the structure members. And here he has declared a structure with which is referring to the pointer structure, which is referring to the same name. Here struct node asterisk link. So node is the name of the structure itself. It is referring to the same name, same self, referring to the self structure. Okay, so that is nothing but the self-referential structures. Self-referential structures are those structures that have one or more pointers which point to the same type of structure as their member. So if you see here, these are the three members, and the third member is referring to the same structure. So these are nothing but the self-referential structures. Okay, let us see a PPT in detail regarding the structures, a simple presentation regarding the structures. So sorry, regarding the pointers. So if you go with the thing, pointers, if you see here, pointers are nothing but the derived data types. Okay, in the derived data types, pointer is one of the type. And here, when you go with the pointers, when we remember pointers, or else when you come up with pointers, when you are dealing about the pointers, the three things you have to keep it in mind. Three concepts associated with the pointers: the pointer constants, pointer values, and the pointer variables. So what are these? pointer constants, pointer variables. Let us see. Okay, so if you declare a pointer, right, right, so now I have declared a pointer. So what is my pointer? Int star p is my pointer, right? So this is my pointer. Now this pointer will be having some address, right? So this is a pointer p here, and this pointer is having some address. So what is the address of this pointer? Some 5000, let us assume. So here I have assigned a normal variable I j. Let us take, okay. So for which variable I have to assign, let me give here, I am assigning the address of I, right? So here this is I, and the address of I is, here I am giving the address of I. Address of I is 2000. So as I have said to the pointer p to hold the address of I, so here p is holding the value 2000, right? So p is holding the value 2000 here, which is the address of I. So here you can say, we are discussing about the pointer constants. So for every pointer there will be a constant. This constant is nothing but the 5000 value, like addresses that never change, that doesn't change. Okay, addresses are nothing but the constants. Okay, pointer constants, if you refer to the pointer constants, are nothing but the addresses. Okay, so next, pointer values. Okay, so which address it is holding, so this is the value of the particular pointer, we can say. Okay, and here it is a asterisk p is the pointer variable. Okay, so these are the three terminologies used when you are talking about the pointers. Okay, so next, pointer constants. Here I'm just briefly giving you the definition. The computer's memory is a sequential location of storage cells. Each cell can hold a byte of information, has a unique number associated with it, is called address. We cannot change the address, but we can use them to store data, right? So the memory address are called pointer constants. The memory address which we are storing the values are called pointer constants. Here you can see the variable name, and here the address, and here these are the pointer constants. Okay, so next, pointer value. Whenever we declare a variable, the system allocates the appropriate location to hold the value of the variable somewhere in the memory. Consider the following declaration: int I equals to 10. So here he has declared the value of I as 10. This is a variable value. Okay, so reserve the space in the memory to hold the integer value. Here, to hold the integer value, it is holding some space. To give the value, to give a place for 10, it is holding, the memory is holding some space, and it has given the name I, and the value is 10 at this location. We can represent the ith location in the memory by following memory map. Okay, if you can see here, he has given the variable name I, address like variable value 10, and the variable address is some randomly has given some address, right? So next thing is the ampersand operator. So to access the variables, like assign the address of a pointer, we will be giving the ampersand, and to access the address, we will be giving the percentile u. Next, these are the things that we have discussed. Pointer declaration and definition. Yes, pointer data type and the star pointer name, that is pointer declaration. Data types must be of a pointer must be the same data type of the variable to which the pointer variable is pointing. Okay, if you want to declare an integer pointer, then go for the that. In the sense, I'll just show you. I'm just assigning here the value of integer is something 20. So here I want to access the value of I. So I am giving the pointer as integer also. Now if I want to assign, here I have given the C some K. Okay, so I want to assign the address of character. So what I have to give? I have to give char star chp character pointer. Okay, so the you have, if you want to store a character value, to point a character value to a character value, you have to declare a character pointer. Okay, so here the pointer initialization, address operator is nothing but the reference operator. So these are all the things about the pointers. In the next session, let us discuss about what is the remaining next unit. For the next unit, let us quickly go to the next unit in the another video sessions. Thank you all.